question revolves around whether an interior section of a metallic water pipe can be considered part of the grounding electrode system. Specifically, if a 10-foot underground metallic and electrically continuous pipe emerges from the ground inside a building and continues for 5 feet without interruption, can that 5-foot section be considered part of the grounding electrode? The answer is that only the underground portion, the 10 feet, can be considered the grounding electrode. The 5-foot exposed and interior pipe is considered a valid connection point. Now let's delve into the specifics of grounding electrode systems and the reasons behind this distinction. A grounding electrode system is designed to provide a low impedance path to earth, ensuring that electrical faults can be safely conducted to ground, tripping circuit breakers or fuses and preventing electrical shock hazards. Metal underground water pipes are a common and effective type of grounding electrode when properly installed. However, there are specific requirements that govern their use as grounding electrodes, primarily dictated by the National Electrical Code, or NEC. The NEC outlines what constitutes a suitable grounding electrode. For a metal underground water pipe to qualify as a grounding electrode, it must be in direct contact with the earth for a minimum of 10 feet. This requirement ensures sufficient contact with the earth to provide a reliable grounding path. The code emphasizes the importance of the underground portion of the pipe because the earth provides a stable and consistent reference point for grounding. The section of the pipe that is underground benefits from the earth's natural conductivity and large surface area contact, which helps dissipate fault currents effectively. The portion of the water pipe that is inside the building, even if it is electrically continuous with the underground section, does not meet the same criteria for direct contact with the earth. This is because the interior section of the pipe is typically isolated from the earth by the building structure, such as concrete foundations or other non-conductive materials. This isolation reduces the effectiveness of the interior section as a grounding electrode. The primary function of the interior pipe section is to serve as a bonding and connection point for the grounding electrode conductor. This conductor connects the grounding electrode to the building's electrical system, typically at the service equipment. The NEC requires that the grounding electrode conductor be connected to the metal water pipe within 5 feet of its point of entrance to the building. This requirement ensures that the connection is made as close as possible to the grounding electrode, minimizing impedance and maximizing the effectiveness of the grounding path. Now, let's consider the potential issues that could arise if the interior section of the pipe were considered part of the grounding electrode. Firstly, changes to the plumbing system inside the building could inadvertently compromise the grounding electrode. For instance, if a section of the interior pipe were replaced with a non-conductive material, such as PVC, the electrical continuity of the grounding path would be broken. This could leave the electrical system without a proper grounding electrode, creating a safety hazard. Secondly, the interior section of the pipe is more susceptible to corrosion and damage than the underground section. Exposure to air temperature fluctuations and contact with dissimilar metals can accelerate corrosion, which can increase the impedance of the grounding path. This increased impedance can reduce the effectiveness of the grounding electrode, making it less able to safely conduct fault currents. Thirdly, the interior section of the pipe may be subject to modifications or alterations that could affect its electrical characteristics. For example, the addition of fittings, valves, or other plumbing components could introduce resistance into the grounding path, reducing its effectiveness. In contrast, the underground section of the pipe is relatively stable and less likely to be altered or damaged. This stability is essential for maintaining a reliable grounding electrode. It's important to note that the NEC also requires supplemental grounding electrodes in addition to the metal water pipe. These supplemental electrodes, such as ground rods or ground rings, provide additional grounding paths in case the water pipe is compromised or disconnected. This redundancy helps ensure that the electrical system remains adequately grounded at all times. When installing a metal water pipe as a grounding electrode, it is crucial to follow the NEC guidelines carefully. Firstly, the pipe must be metallic and electrically continuous. Secondly, it must be in direct contact with the earth for at least 10 feet. Thirdly, the grounding electrode conductor must be connected to the pipe within 5 feet of its point of entrance to the building. Fourthly, supplemental grounding electrodes must be installed as required by the NEC. Failure to comply with these requirements can result in an ineffective grounding system, which can increase the risk of electrical shock, fire, and equipment damage. Grounding electrode systems are designed to protect people and property from electrical hazards. By understanding the requirements for metal water pipes as grounding electrodes, electricians and installers can ensure that these systems are properly installed and maintained. This helps create a safer electrical environment for everyone. To summarize, only the 10-foot underground portion of a metallic water pipe can be considered the grounding electrode. The interior section of the pipe serves as a connection point for the grounding electrode conductor. Following NEC guidelines is essential for ensuring a safe and effective grounding system. The NEC provides specific guidelines for grounding electrode systems, including requirements for metal water pipes. It's important to consult the latest edition of the NEC and adhere to these guidelines when installing or maintaining grounding systems. Additionally, local codes and regulations may have additional requirements that must be followed. Firstly, a metal underground water pipe used as a grounding electrode must be in direct contact with the earth for at least 10 feet. Secondly, the grounding electrode conductor must be connected to the water pipe within 5 feet of its entrance to the building. Thirdly, supplemental grounding electrodes, such as ground rods or ground rings, are typically required in addition to the water pipe. Fourthly, the water pipe must be electrically continuous, meaning that there must be a continuous metallic path from the underground section to the point where the grounding electrode conductor is connected. Fifthly, any non-conductive sections of the water pipe, such as plastic fittings or couplings, must be bonded around to ensure electrical continuity. Sixthly, the grounding electrode conductor must be sized appropriately based on the size of the service entrance conductors. Seventhly, the connection to the water pipe must be made using approved fittings and methods. Eighthly, the grounding electrode system must be inspected and tested to verify its effectiveness. Ninthly, any changes or modifications to the water pipe system must be carefully evaluated to ensure that they do not compromise the grounding electrode. Tenthly, regular maintenance and inspections of the grounding electrode system are essential to ensure its continued effectiveness. Proper grounding is crucial for electrical safety. By adhering to the NEC and other applicable codes and standards, you can help protect people and property from electrical hazards. Remember to consult with a qualified electrician or electrical engineer if you have any questions or concerns about grounding electrode systems. Understanding the distinction between the grounding electrode and the connection point is vital for proper grounding system design and installation.